We now come to our fourth speaker, Torsten MAYR, Deputy Head of the Institute of Analytical Chemistry and Food Chemistry here at Graz University of Technology. And also nicely fitting as the talk afterwards, as we had heard something about organ-on-chip and sensors. So he is a real expert also on that. But I don't want to take too much from your time. So Torsten, the floor is yours. Looking forward to your nice presentation.
Okay, so I think all technical issues have resolved, yes. So we can start. Okay, yeah, thank you for the kind introduction. It's also a pleasure for me really to join this Gold Member Webinar, because I was also in contact with Andreas when he was founding BioNanoNet, and I'm on board since this time, and it's a really successful time. He helped me already in a lot of times to really to run projects and to find project partners. Yes, so TU Graz is a university in one of the 5 universities in Styria in Austria. It was founded in 1811 by Archduke John of Austria, and it has currently 7 faculties. And it offers for students 18 bachelor and 33 master student programs. And this is all across technology and natural science disciplines. So now, okay, so as I said, we have 7 faculties at the TU Graz. So, and it's very, very broad range. So this, it spans from agriculture, civil engineering, and we have mechanical engineering and economic sciences, then electrical and information engineering, the faculty of mathematics, physics, and geodesy, and then we have the technical chemistry, chemical and process engineering, and biotechnology summarized in one faculty, and we have the computer science and biomedical engineering. So you see, it's a wide span of disciplines and natural science topics. So facts and figures, just in brief, total Graz staff is in total about 3,600 people, whereof is academic staff is 1,700 round, and non-academic staff is 1,000, and lecturers about 830. So, and to this, you have also to account that there's some subsidiaries of the TU Graz, and there we have again, another 1,300 employees. How many students are studying at the TU Graz? So it's in total, it's 13,566. And it was this numbers from 1920, and each year about 2,000 students start their studies at the TU Graz. So there is the TU Graz has also structured its research in 5 fields of expertise, comparable to the TU Wien we have heard before. So, and the research is also reflected in it has in leading positions in the Austrian competence centers of the FFG COMET program. So a lot of participation in this program, and this is also showing the good relationship and cooperation of science and industry in the region, or also Austrian-wide and in world in whole Europe. So, and TU Graz is also involved in more than 60 Horizon 2020 projects, and this including 7 ERC grants, and also with the very renowned running 14 very renowned Christian Doppler laboratories, and several many FFG and FW projects. So third part funding is also very important at TU Graz. So TU Graz is structured in 5 fields of expertise. Here institutes are collected together or summarized in topics. And so at the I want to start with the human and biotechnology. field of expertise. So here you can find biomedical engineering, molecular biomedicine, and industrial and environmental biotechnologies. So it doesn't move. Next slide. Something is frozen now.
Okay.
So it's now we have the next slide. So this is advanced materials. So, and this is focusing on development of new materials and research of new materials and also the processes. And this includes also that we look at the structure determination using microanalytics and nanoanalytics. And also this is then supported also by modeling of these new materials. And then we have information, communication, and computing. So here, as you can probably can think of, you have algorithms, mathematical modeling. So we have smart systems, intelligent communication. There's also sensor systems, and also multimedia processes and structures that are summarized in this research area. So it is really difficult, but I cannot. Okay, the next is mobility and production. So, and here you see this has also a tradition in Styria, of course. So this is has a lot to do with engines and powertrains, but also the hot topic at the moment, electromobility and hydrogen-based mobility, but also active and passive safety. And here is also production and process technology involved. And then we go to a different field, so where more architecture and construction is felt. This is sustainable systems. So we have urban and mobility planning, so sustainable construction, and also future-oriented energy systems. So very important field for the future. And so these fields in research, they are characterized by excellent focused research, and they really work interdisciplinary, and this is then results in an intensive collaboration between different institutes from different faculties, but also with business and industry. So, and from this, we have these field of expertise have strategic partnerships in national and international and scientific organization. And also from these field of expertise, there's a huge participation in competence centers and research networks. And yes, and I'm a representative of the Institute of Analytical Chemistry. And now I want to explain a little bit more about our institute as a partner of BioNanoNet. So we have the institute is structured in 4 working groups. So first is conventional analytical chemistry. Let's say you dealing with element analysis and applied spectroscopy. Here and here, Elmar, which is an expert in sample digesting using microwaves. And then we have another interesting field that is analyzing food, and taste. So it's the group of food chemistry and sensory analysis. Erich Leitner and Barbara Siegmund really look into the taste and smell of food, and they use also the human taste sense and correlate this with analytical techniques. And then another big part of the institute is dealing with optical sensor technology. So, and this is the group for sensor materials led by Sergei Borisov, and the group of applied sensors, which is my work group. So it is still difficult, but it does not move, and I don't understand this.
Maybe it's because you use this cursor to point.
Really?
Maybe
okay.
It could be just one of the options.
Is it now? Okay. Okay, now it's better. So I will skip this slide. And so, the sensor research for optical sensors is really covering from the basic research to the application of this sensor. So basic research means we synthesize new materials, new indicator dyes in new polymers, and then we prepare from these new materials, sensor materials that we characterize and also adjust them to a certain application, and build around these readout instrument, and also bring them really apply this, because this is also often a challenge if you have a sensor material that you really can apply it to a specific question. And these the last 2 points we do in collaboration with partners from industry, but also with academic partners. So, and yes, applications fields in our we looking into is medical diagnostics. So we have a long-term collaboration with a diagnostic company, and we also look into environmental analysis, in particular for marine sciences. So we build sensors that we can that can be also used in the deep sea applications to measure oxygen and pH, and also for process analytics and biotechnology. And the newest field is concrete analysis. So we want to elucidate the status of construction of buildings. So we want to analyze the construction materials by using our optical sensing and imaging techniques. So in here below you see the analyze that we are interested in, or that we can that we are using. So now I come to a topic that is microfluidics. We have seen also before from the TU Wien, and also for an organ on chip. So we are interested, we want integrating our sensors in microfluidic devices. So these really small and micro scale devices with sizes below 100 micrometers, where you can grow cells in, and you want to monitor and control then these several parameters of these culture conditions. So this is one branch that you can really use the monitor and control the parameters like oxygen or pH. And the other thing is what we can do with our sensors. We can look at the cell viability or the metabolic stage, because the cell consume oxygen or glucose and release proteins. And this we can then, from these sensor readouts, we can then obtain the metabolic data and use them for disease and toxicity models. Of course, we do that again with collaboration partners. And here is an example, a chip that we made together with TU Wien and KDG, and in an FFG project. You see here, this is a microfluidic cell culture chip, and this is the cell chamber in the middle, where the adherent cells are grown, and you see also the green dots here are the sensor spot that we use then for the readout, the metabolic. So, and this can be then used for organ on chips and cell cultures, but also in microbioreactors, or we also have projects in flow chemistry. So we are looking for collaborations with various partners in various fields. As you've seen, we have a lot of application fields. So it can be in screening of nanomaterials or nanotoxicology or drug screening, when we use the metabolic response of our sensors. Or in general, we are interested in implement our sensor technology, these small tiny dots in any kinds of microsystems where it can be useful, microfluidic systems, but it can be also these variables, or what is at the moment in vogue. So, and also we are looking want to improve our carbon dioxide sensors for aqueous monitoring. You probably know that this ocean acidification is a huge problem because of the climate change, and the combustion and the exposure of carbon dioxide. So this would be there's a tremendous interest in these sensors, and we also interested in ammonia sensors for aqua farming, and also in projects where you can apply our sensors for analysis of construction materials. So then I want to also maybe I hope I can give you an overview of TU Graz, but also of the things that we are doing at our institute. And I want to say thank you for your attention and apologize for the technical issues.